Hello students, this is the second video for statistics. Today the pages that we are going to be looking at in your packet are sample spaces and tree diagrams. We will go through the vocabulary words and make a tree diagram. There it says page 3 in your packet. Then we will be going through some examples of the counting principle that are on page 4 and practice making a tree diagram. And then your assignment is going to be that next page called page 5, which is the last page in your packets. So let's get started with the lesson. So here we are talking about sample spaces and tree diagrams. Now a sample space is a collection of all the possible outcomes of an experiment. And an experiment could be placing an order for a turkey sandwich at Panera Bread. Or it could be choosing the features that you want to make sure are in a car that you're going to choose or that your parents are going to buy. So that's a collection of all the possible outcomes. We are able to show these different possibilities using a tree diagram. And you will see just below here on this paper is, let me get here to my pen tool here, is an example of a tree diagram. We're going to be filling in some samples for choosing a computer and a printer. Another concept we're going to be doing in order to find the number of outcomes in a sample space is that we are going to be using something called the fundamental counting principle. So if, for example, we can order from a menu with a certain number of ways to choose the meat for your sandwich. And then there are a certain number of bread choices that you could choose from. Then to find the entire event, how many different sandwiches can be made, we would multiply the combinations. For example, we have here at an electronics store, they offer a desktop computer with a choice of 2 monitors. That's like the TV screen. You could get 15-inch or 17-inch. And they're going to give you a printer, which can be either inkjet printer or a laser printer. If we use this counting principle to find out how many outcomes we're going to have, we're going to do 2 monitors times 2 printers will give you 4 different combinations of computers and printers. Okay, so now let's make a visual diagram of the different options for this event or this experiment. First, we are going to start with this tree diagram. What are we doing? We're making a computer. And what are our first choices? We have 2 first choices for the monitor. If you recall, up in the top here, it says that we have a choice between a 15-inch or a 17-inch monitor. And if we were to choose this 15-inch monitor, we then have 2 choices for our printer. We could choose from the inkjet or the laser. But suppose we choose the 17-inch monitor. It's not like our printer options have changed. They are still the same inkjet and laser. Now up in our definition of a tree diagram, it said that each path or each branch is a visual way to show these outcomes. So if you follow my turquoise highlighter across our tree diagram, one option is 15-inch and inkjet, so there's one option. Another option is 15-inch and the laser printer, so we've got 1, 2. Then we could have 17-inch monitor with the inkjet. There's a third option, and the last path or branch gives you that same 4 that we got using the counting principle. All right, I was talking before about Panera Bread, so let's go down and take a look at this one here. Example 2. I reduced by, it looks like a choice, and just so that's why you can see this little scribbly stuff here. Don't mind that. For lunch at the Sharp overnight trip, if you remember going to Sharp as elementary schooler. For lunch, they had a choice between ham, turkey, or a cheese sandwich, followed by an apple or a banana, and finally they could get either juice or milk. So first, for part A, let's use the counting principle to determine the number of lunch combinations. And when I say to show all of your work, I want you to show the different options for sandwich, fruit, juice. So what is the counting principle for sandwich, fruit, and juice? 3 choices for sandwich, 2 choices for fruit, 2 choices for that drink. 3 times 2 is 6 times your 2. So that gives you 12 using the counting principle, 12 outcomes. Now we're going to, for part B, create a tree diagram. So for this tree diagram, we are creating lunch. And first we've got a sandwich. So our sandwiches include ham, I'm going to use an H, turkey, I'm going to use a T, and a cheese sandwich, I'm going to use a C. Now it's time for the fruit options. I'm going to use A for apple and B for banana. And don't forget now we've got a drink combination. We could get apple juice, I'm going to call A J, or we could get milk, which I'll call M. Well, not only does all of this stuff have to happen up in this portion, but now we have to draw the rest of the tree for the turkey sandwich, for the cheese sandwich, and also finish the remaining part for if we were to choose a banana. So let's go and finish our tree diagram for apple juice and milk, apple, banana, apple, banana. Please be filling this in your chart. If you're running out of room, you'll now recognize that for your homework, you'll need to make sure that you leave yourself enough room. Apple juice, milk, apple juice, milk, apple juice, milk, apple juice, and you can see I'm falling out of the page here. Milk. So we said that there were 12 different combinations. I'm going to grab my highlighter. I'm going to use yellow. Let's follow the branches. There should be 12 if we've made a correct tree diagram. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. That matches our example using the counting principle. Take a moment now, following along with the Edpuzzle video, and answer questions 1 through 6. Then we will scroll down here and we're going to practice making tables and practice showing that sample space. And then the very last page is your homework assignment. So let's go back and we'll answer questions 1 through 6 using the Edpuzzle video.